We're just bombarded with information all day long, right? Claims, counterclaims, it's a lot. So how do we actually cut through all that noise? For centuries, humanity's best answer has been science. Think about it. It's the engine that's mapped the entire cosmos, wiped out diseases, and literally built the world we live in. But what is this thing we call science, really?
And that really brings us to the big one, the most fundamental question there is. How do we actually separate what's real from what's not? How do we tell fact from fiction? The answer, it turns out, isn't just about memorizing a bunch of facts. It's about a whole way of thinking.
And right here, this is the heart of it all. See, science isn't just, a dusty old textbook full of facts. No way. It's a living, breathing, rigorous process. It's our single most reliable tool for figuring out how the universe actually works.
So, here's how we're going to break this down. First, we'll ask, what is science really? Then we'll look at knowing versus just guessing. After that, we'll dive into the scientist's toolkit and we'll tackle a huge myth about the word theory. And finally, we'll talk about the awesome power of science and its limits.
All right, first up, what is science, really? It's more than just a pile of facts. It's a process of discovery. Look, it's so easy to think of science as this big encyclopedia of stuff we know, but that's not it at all. It's this dynamic, constantly updating process for finding things out. The key thing to get is that science is a verb. It's something you do.
So the word science actually comes from the Latin word scientia, which just means knowledge, but it's a really special kind of knowledge. It's knowledge that's built on a super systematic process of observing, experimenting, and reasoning. And what's so crucial about this system is that it's designed specifically to help us get past our own biases and our often wrong gut feelings.
Okay, next section. Knowing versus guessing. We're going to look at how science's approach is so different. Because once you get this system, you really start to see the huge difference between knowing something in a scientific sense and just, guessing or believing it.
And this really lays it all out, right? On one side, you have other ways of knowing things. Your gut feeling, what you've always been told, what an expert says, and hey, we use those all the time. But the scientific way is different. It demands hard evidence, stuff you can actually see and measure, and insists that experiments have to be repeatable by other people. And it's built on this foundation of healthy skepticism. You're always questioning, always checking.
And this leads to a really cool and honestly beautiful idea. Scientific knowledge is provisional. Now, that doesn't mean it's flimsy or weak, not at all. It means it's honest. It's our best current understanding, and it's always open to getting better when new evidence pops up. A great example is Einstein and Newton. Einstein's theories on relativity didn't just throw Newton's laws of gravity in the trash. They showed that Newton's laws were a brilliant but incomplete picture of reality. Science is always ready to update the map.
So, Section 3, the Scientist's Toolkit. We're talking about the two pillars of scientific investigation. So how do scientists actually get all this evidence that lets them keep refining our understanding? What's in their toolkit? Well, it really comes down to two main things.
First up is the power of observation. And we're not just talking about casually looking at stuff. Scientific observation is systematic. It's planned. And we often use incredible tools like telescopes or microscopes to extend our senses way beyond what's normally possible. And here's the kicker. It actually rewards you for noticing the weird stuff, the unexpected details that don't quite fit. The discovery of penicillin? It all started because Alexander Fleming just happened to notice a little clear spot around some mold in a petri dish. That was it.
And the second big tool is the experiment. I love this because an experiment is basically a question you ask nature, but you ask it under really controlled conditions so you can figure out cause and effect. It's not passive at all, it's you actively poking the universe to see how it responds. And the secret sauce here is the control group. It's pure genius because it lets you see what would have happened if you had done nothing at all. That's how you know your actions actually caused the change. So you take these two things, observation and experimentation, and they come together in this powerful cycle. It goes like this. You observe something and ask a question. Then you come up with a testable guess, a hypothesis. Then you design an experiment to see if you're right. And then you analyze what happened and refine your idea. It's a loop, a never-ending loop of discovery that just keeps going.
And at the very heart of this whole thing is something you might not expect, humility. A deep humility before the evidence. It's the willingness to be wrong, to completely drop a beautiful idea that you love if the evidence says, nope. And that's not a weakness, not at all. It is, without a doubt, science's greatest strength.
All right, our next section gets into something really important. Theories aren't just guesses. This is all about understanding science's greatest achievements. And honestly, this might be one of the biggest misconceptions about science out there. And it all comes down to one little word: theory.
Here's the deal. In everyday conversation, when we say theory, we usually mean a hunch, right? A guess. I have a theory about why the traffic is so bad. But in science, it is the exact opposite. A scientific theory isn't a starting point. It's the finish line. It's the gold medal. It's the crowning achievement of a ton of work.
So, what is a scientific theory? It's a massive, well-supported explanation for a big chunk of how nature works. It's backed by mountains of evidence, and it makes predictions we can test. I'm talking about giants like the theory of evolution, or atomic theory, or the germ theory of disease. These aren't just hunches. They are powerful frameworks that have been tested again and again and again and have come out on top every time.
This table breaks it down perfectly. A scientific law versus a scientific theory. A law's job is to describe what happens. Think of Newton's law of gravitation. It describes the force of gravity with a neat little equation. It tells you what's going to happen. But a theory's job is to explain why it happens. Einstein's theory of relativity comes along and gives us the why behind gravity. It explains it as a curve in spacetime. So law tells you what, theory tells you why. It's a great distinction to remember.
Okay, on to our last section, science's power and limits. Let's talk about what science can and can't do. Now that we've got a better handle on how this whole process works, we can really appreciate just how powerful it is, and also, just as importantly, where its boundaries are.
I mean, the power of science is it's all around us. It's undeniable. From the medicine that keeps us healthy, to the technology that connects us, to the food we eat, pretty much every single aspect of modern life has been fundamentally shaped by science. The phone in your hand, the lights in your room, that's the proof right there. The method just plain works.
But, and this is a big but, science has limits. Its playground is the natural world, the stuff we can actually test and measure. So, science can tell us how to do something incredible, like clone a mammoth, but it can't tell us if we should. It can't answer questions about morality or meaning or purpose. Those are questions for philosophy, for ethics, for us as a society. Science gives us the data, but we still have to make the call.
And that really brings us to the main takeaway, the big idea. The goal of science isn't to find some final, absolute truth with a capital T that never changes. No, the goal is the process itself. It's this ongoing journey of building a better, more reliable, and frankly, more amazing understanding of the universe. It's about getting closer and closer to what's real. So, I want to leave you with this question. The biggest mysteries are still out there, right? The nature of consciousness, whether we're alone in the universe, so much we don't know. So I'm curious, what mystery do you hope science tackles next?